The photography project is an assignment in which we complete over a 4-month time period. During the extent of this project, we will be using 35mm cameras to take our pictures, and we will be developing our film. In doing so, we will be able to learn the chemistry behind film development and the chemistry of how photos are taken. We will also have an additional 11 sections needed to be completed by the end of the year. In addition to this, we will be researching the chemical composition of every item in our pictures. This project challenges us to have excellent time management, develop our researching abilities, and to increase our creativity in the format we have drawn from a hat. Hello, this is Artifact in another episode. First, we are examining Camera Obscura. It was created by Ibn al-Haytham. People of ancient times figured out a way to take pictures by using this phenomenon called camera obscura, or commonly referred to as the pinhole camera. It has the shape of a closed box with a small hole on the outside, and when light comes through, rectilinear propagation of light creates an image on the opposite outside of the box. I am Johannes Scholz, and I will darken the silver with heat. Why is it not working? And now we shall use direct sunlight. Aha! The silvers, they have darkened. But why does it not last forever? By using silver nitrate, I was able to create the picture, but I only get the dark outline of it. By using nitric acid, I was able to recreate my picture. But why does my picture never stay? I have already added a bitumen of Judea, and I have added my lavender oil. But I need direct sunlight. I'm not doing that. It worked! I have completed it. I shall call it daguerreotype. A little bit of sodium chloride. A little bit of silver nitrate. I've done it. This paper is now more light sensitive than the rest. I'm gonna fix these negatives with sodium hyposulfide. Later we should call it sodium thiosulfate. Now I'm gonna wax the paper before printing to reduce the grain of this paper. I suggest the name photograph to tablet. I've made this process 20 times faster. I'm gonna use it by using wood glass plates. They are negative though. I'm gonna call this process collodion, and it is a solution of nitrocellulose in alcohol and ether. When they evaporated, a plastic-like film is formed. These chemicals are impervious to water, and they expose silver halides and remove the unexposed salts that could not penetrate the coating. The issue with this process is that a photographer had to sensitize the plate immediately before exposure, and had to do it while it's completely moist, which means I can't do anything but just sit here and wait. I have discovered a way to change the color of the ribbon. I have suspended the silver bromide in this gelatin emulsion. By doing this, I made it 60 times more sensitive than the old plates. And in this method, I have successfully replaced tripods, and we can enter the era of portable cameras. The year is 1833. I produced the first Kodak camera. This camera has a glass plate that contains a roll of flexible negative material capable of taking 100 pictures. Now once you press, you take it to the factory and they will process it for you. I see it. Using cathode rays, I have discovered the first X-ray. Now created a camera capable of taking pictures of moving things at high speeds. Got it. Introducing the Polaroid.
Forget about me. The film, the most important part of the camera. I am a thin, flexible strip of plastic or other material, coated with light-sensitive emulsion for exposure in a camera, used to produce photographs or motion pictures. I'm taken out of the camera when it's time to develop the picture. You also forgot the chemicals involved in film development process. Those are silver bromide, potassium iodide, potassium bromide plus distilled water, and which is H2O, and they make up the job too. You also forgot about silver halide salt. They're chemical combinations of silver, iodide, and bromide, which form crystals.
Created using Powtoon.
This is I, Lineage Blur, and I am coming from the future where they were able to put my brain. It is kind of glitchy though. The film and developer react. The developer's job is to make the latent image visible. It donates an electron to the silver ion Ag, ultimately meaning that the developer is being oxidized. The reaction that takes place is Ag positive plus E minus equals Ag reduced metal, in which E stands for the developer. The developer is giving one of its electrons to the silver metal. Since the developer is being oxidized, the silver metal left on the film makes the image visible. If there is excess of the developer, the equation can be modeled as unreacted AGBR plus developer equals over replacement over development.
From there is the stop bath. The stop bath is used to stop the reaction between the film and the developer. In other words, a competitive reaction is occurring, also known as acid-base neutralization. The developer is an acid, and the stop bath is trying to bring its pH closer to 7. The equation that models this relationship is HOH plus 2HC2H3O2 equals C2H3O2 and C2H3O2 plus 2H2O.
After this, the fixer and the film reaction is taking place. The fixer is made up of two solutions. Its main job is to make the image permanent and react with the film to convert any unreacted AGBR to make it insensitive to light. Two equations occur in this relationship. The first one is NH4 to S2O3 plus AGBR unreacted equals NH4Br plus NH45 permanent and AgS2O3 free. Silver bromide reacts with ammonium sulfite to get ammonium bromide and silver sulfite, which is insoluble. We did 10 washes to remove any unnecessary materials and other things left on the film. Staying between 40 and 90 degrees Fahrenheit, the permawash must stay maintained at a certain temperature. It is a soap and a type of base, and is also used to remove anything left on the film. It removes silver sulfites, developer fixer, and other materials. It is made by Heiko and contains ammonium sulfite and sodium sulfite. The equation for this relationship is 2AGBr plus NH4 2SO3 equals 2NH4Br plus Ag2SO3. Photo flow has no equation. Its only task is to act as a protector and laminator to make the film soft and pliable. My machine finally works, but I must leave now, for I have remained in the past too long.
Overview. The idea of this lab is that we wanted to recreate the development of photographs, as well as discovering the chemistry behind this process. Procedure. We had to pre-soak with water for a minute. This allowed there to be enough time for me and Dave to get the developer to 21 degrees. After 1 minute, we went straight to the developer. For 9.5 minutes, Jagnor was telling Danny when to agitate and when to rest. Next, we had to quickly dump the developer. Then, immediately after, we had to put the stop bath into the tank. We had the stop bath in for about 2 minutes. We had to rest for 30 seconds and agitate for 5. After we did 2 wash and dumps. After this step, we went straight to the fixer. The most important thing to do is to not drop it down the drain. This should not be done, for it is a heavy metal that could cause clogging. We had to use the fixer for approximately 7 minutes, with 30 seconds on, 5 seconds off. After you pour it into a waste bottle when done, your first wash, 10 wash and dumps, occurs. Next, we had the perma Washington for 1 minute, Danny agitated it and then dumped it out. From there, we had to do 30 wash and dumps to make sure we got absolutely everything out. Lastly, we put the photo flow in for about 30 seconds and removed that too. We took out the film and gave it to Ms. Smith to dry for about an hour. While she was hanging them up to dry, we cleaned up the same way we normally would during a normal lab. The results we got were surprising. At the end, our film came out decent. We were able to see all of our images without the light box, but there were some uneven points. Jagnor's pictures came out very dark in comparison to mine, which were a more even image. Not only that, but our film was darker than it should have been. We all worked well together. Our solutions were always at 21 degrees Celsius, and we only messed up the timing once. However, Danny's agitation was going a bit too fast, and not really that consistent. We learned tons from this lab. We learned how to make the film permanently stay on the film, how to agitate, and the effects that lead from either overdevelopment or underdevelopment. We all did our parts, except for a few mistakes. First off, the images were a little bit uneven and overdeveloped. This was because we did not have enough developer for both reels and because agitation was not consistent. We also dumped the fixer down the drain. This lab showed us that just the slightest mistake can throw off your entire film. In the case of the other groups, they had shaken fast, and had not allowed any reaction to take place. In the case of Carolyn's group, they did it perfectly. We did bicker at some points during the lab, but it allowed us to experience photo developing and to do it ourselves.
The developer is a Kodak Professional D76. The developer is a base, which means it has a pH of over 7. The chemicals that make up the developer are
hydroquinone, bis-4-hydroxy, N-methylenium sulfate, water, which is H2O, metal, which is C7H10NO2SO4.
There's sodium carbonate, Na2CO3, sodium sulfide, Na2SO3, and granular borax, Na2B4O5OH48H2O.
The stop bath is an acid. This means that the stop bath has a pH of less than 7 because its purpose is to stop the reaction. The stop bath is a Kodak Professional indicator stop bath. It is made up of the acetic acid CH3COOH. The fixer has two solutions and is called the fixer Kodak Professional. Solution A contains ammonium sulfite NH42SO3, sodium bisulfite NaHSO3, ammonium thiosulfite, sodium acetate C2H3NaO2, and water H2O. Solution B contains sulfuric acid H2SO4, aluminum sulfate Al2SO43, and water H2O.
The permawash is a Hyco HG85. It's made of ammonium sulfite NH42SO3 and sodium sulfite Na2SO3.
PhotoFlow is a Kodak Professional PhotoFlow. Is a polymer made of p-terroxyphenoxypolyethyl alcohol. Also made of propylene glycol. Uses a preserver C3H8O2 and water, which is H2O. In the first picture, the first item is a book. A book is composed of cardboard, which is made up of layers of paper. Paper contains cellulose and lignin. Cellulose has a chemical formula of C6H10O5N, and lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4. Paper is made of cotton, almost purely cellulose. It's also made of pulpwood fiber, which is made by separating cellulose from wood and waste. It's also made of lignin and hemicellulose. Like I said before, cellulose is C6H10O5N. Lignin is C9H10O2, C10H12O3, C11H14O4, and hemicellulose is C6H10O5. The chalkboard is composed of limestone, and the tray is made of metal. The chemical name is calcite, and calcite is the chemical formula of CaCO3. We have a human. For humans, we are made up of skin and bones. Skin is made up of keratin, which is actinolite, and bones are made up of calcium phosphate and calcium carbonate, as well as collagen. The chemical names are actinolate. An actinolate has a chemical formula of Ca2, Mg 4.5, 2.5, Fe2 plus 0.5, 2.5, Si8, O22, OH2. Calcium phosphate has a chemical formula of Ca3PO42. Calcium carbonate has a chemical formula of CaCO3. And collagen has a chemical formula of C2H5NOC5, H8NOC5, H10NO2. For the poster, it's made up of paper. Paper is made up of cotton, which is purely cellulose. It's also made up of pulpwood fiber, which is made by separating cellulose from wood and waste. It's also made of lignin and hemicellulose. Cellulose has a chemical formula of C6H10O5, and lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4, and hemicellulose has a chemical formula of C6H10O5. The poster in the frame is made up of paper and pulpwood fiber, and as I said before, they're made up of cellulose and lignin and hemicellulose. Cellulose has a chemical formula of C6H10O5N. Lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4, and hemicellulose is made of C6H10O5. For shirts are usually made up of 100% cotton, which is cellulose. Cellulose has a chemical formula of C6H10O5. The pants, which are jeans are made up of either denim or dungaree cloth. Dungaree is made up of cotton and indigo plants. Cellulose has a chemical formula of C6H10O5, while indigo dye has a chemical formula of C16H12N2O2. For the shelving unit is primarily made of wood, and wood is made up of hemicellulose, cellulose, and lignin. Cellulose has a chemical formula of C6H10O5N, while lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4. Hemicellulose has a chemical formula of C6H10O5. The countertop shelving part is made up of wood, while the top is made up of cheap marble. Wood is made up of hemicellulose, cellulose, and lignin. The top is made up of calcium carbonate. Calcium carbonate has a chemical formula of CaCO3. Cellulose has a chemical formula of C6H10O5. Lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4. And hemicellulose has a chemical formula of C6H10O5. Chalk is made up of calcium sulfite or calcium carbonate. Calcium sulfite has a chemical formula of CaSO4, while calcium carbonate has a chemical formula of CaCO3. The plastic boxes are made of a heterochain polymers, which are made up of oxygen, nitrogen, and sulfur. An example of plastic would be polyethylene. Polyethylene has a chemical formula of C2H4N. Oxygen has a chemical formula of O, nitrogen N, and sulfur S. Binders. Binders are made up of a plastic called vinyl. The sides are made of isoprene polymer rubber, and the metal ring is nickel-plated metal. Vinyl and methanoate is vinyl is C3H4O2, and isoprene rubber is C5H8. Nickel is Ni. Folders are made up of either plastic or paper pulp with long cellulose. Starch and cellulose is C6H10O5. Plastic container is made up of polyethylene or plastic. It's C10H8N. Styrofoam is made up of a petroleum-based plastic made of styrene monomer called polyestyrene. Polyestyrene is made up of C8H8N. Stapler is a popular models are metal, which are zinc-plated steel, while cheap ones are made of plastic, also made up of isoprene polymer rubber. Zinc has a chemical formula Zn, carbon C, iron Fe, isoprene polymer C5H8. Scissors are made up of carbon steel and are usually plated with nickel or chromium. The handle is made of ABS, acrylonitrile butadiene plastic, and that has a chemical formula of C8H8, C4H6, C3H3N. Iron has a chemical formula Fe, carbon. In the second picture, the plastic bag is made up of a heterochain polymers, which are made up of oxygen, nitrogen, and sulfur. Plastic is also made of plastic, which would be polyethylene. Polyethylene is C2H4N, oxygen O, nitrogen N, sulfur S. The umbrella, parts of the umbrella are made up of aluminum, while the dome part is made up of a nylon synthetic fiber. which goes all the way down to taffeta. Taffeta is a protein and an amino acid. And fibroin, aluminum is Al, cellulose is C6H10O5N, and fibroin is GLYSER, GLYAL, GLYALAN. It's probably the chain. The plastic basket the plastic is made up of a heterochain chain of polymers, which are made of oxygen, nitrogen, and sulfur. Be polyethylene. Polyethylene has a chemical formula of C2H4N, oxygen O, nitrogen N, sulfur S. Soccer balls, the outsides are made of polyester, while the part that holds the air, is made up of a metal called butyl. The chemical names are polyethylene, terephthalate, and polyacetylbutylene. Polyisobutylene is made of C4H8N. Polyethylene is made up of C10H10O4N. Basketballs are exactly the same. Basketballs and footballs, they're made of bottle rubber, outside made of leather. For those two, tan leather is Na2SO4 plus H2O plus CrSO43, and polyobutylene is C4H8N. Cardboard is made up of paper. Paper is made up of cotton, pulpwood, and pulpwood is made up of cellulose and lignin and hemicellulose. Cellulose is C6H10O5N, lignin is C9H10O2, C10H12O3, C11H4O4, hemicellulose is C6H10O5. Cleats, the soles are made up of rubber, as well as boots. Isoprene is C5H8. I think some outsides are made of leather, and leather is Na2SO4 plus H2O plus Cr2SO43, because I know cleats are made up of leather. Folding chairs are made up of plastic for the seating part, metal for parts that fold, and the metal part is aluminum. So polyethylene is C2H4N, aluminum is Al. Dusters are composed of plastic. The duster part is made by feathers, and that's actinolite. And polyethylene is C2H4N. Actinolite is Ca2Mg 4.5 2.5 Fe2 plus 0.05 2.5 Si8O22 OH2. Water is H2O. A shoe rack is made up of wood and aluminum. Wood is made up of cellulose, lignin, and hemicellulose. Cellulose is made up of C6H10O5N, and lignin is made up of C9H10O2, C10H12O3, C11H14O4. Hemicellulose is C6H10O5, and sodium aluminate is NaAlO2. Curtain is made up of silk. Silk is made up of fibroin. Fibroin has a chain GLYSER, GLYALA, GLYALA. A mirror is made up of glass, silica, and lead. Silica is SiO2, lead is Pb. Cement wall and cement floors are both made up of lime, which is calcium oxide, which is CaOH2. A frisbee is made up of polyethylene, which is plastic, C2H4. And that concludes the second picture. In the third picture, napkins are made up of paper, and paper is made up of cotton, and pulpwood is made up of cellulose, lignin, hemicellulose. Cellulose has a chemical formula of C6H10O5N. Lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4. And hemicellulose has a chemical formula of C6H10O5. A fire hydrant is made up of metal, and the foam, which is made up of water, silica, and clay. Dihydrogen oxide, which is water, is made up of H2O. Silica has a chemical formula of SiO2. Cardboard, once again, cardboard is made up of cotton, pulpwood fiber, cellulose, which is C6H10O5N, lignin, C9H10O2, C10H12O3, C11H14O4, hemicellulose, C6H10O5. It's made up of corn. Corn flakes is made of cellulose, lignin, hemicellulose, like I said before. The Cheerio box is made up of the same. Cinnamon Toast Crunch as well. Potatoes are made up of magnesium and phosphorus. Magnesium has Mg, phosphorus is P, as well as cellulose, lignin, hemicellulose, C6H10O5, C9H10O2, C10H12O3, C11H14O4, and C6H10O5. Rice is made up of magnesium and phosphorus as well, Mg and P. The cabin is made up of wood, which is made up of cellulose, lignin, hemicellulose, which is C6H10O5, lignin, C9H10O2, C10H12O3, C11H14O4, hemicellulose, C6H10O5. The coffee maker is made up of plastic, made up of silica, the inside made of silica, the glass part. Silica is SiO2, polyethylene, C2H4N. Syrup is made up of peptides, amino acids. It's made of sucrose, glucose, and fructose. Sucrose is made up of C12H22O11. Dextrose and luvose, which is the chemical names for glucose and fructose, is made up of C6H10O6. Pasta is made up of water and starch. H2O is water, and starch is C6H10O5N. Plastic is made of polyethylene. Polyethylene is C2H4N. Oxygen O, nitrogen N, sulfur S. Bread comes made up of carbohydrates. A carbohydrate has a chemical formula of CmH2ON. And corn is made up of amylose and cellulose and lignin. Amylose has a chemical formula of C6H10O5. Cellulose has a chemical formula of C6H10O5N. And lignin has a chemical formula of C9H10O2, C10H12O3, C11H14O4. For the fourth picture, a faucet is made up of Zamac alloys that contain zinc and aluminum. Zinc has a chemical formula of Zn. Aluminum has a chemical formula of Al. Water has a chemical composition. It's just water. It's made up of dihydrogen monoxide, which is H2O. Rubber gloves are made up of rubber, which is nitrile. Nitrile is a cyanide, which so has a chemical formula of Cn-. Plastic is made up of polyethylene. Polyethylene has a chemical formula of C2H4N. The ceramic figures contain zirconium oxide, which is well as silica. And zirconium oxide is made up of ZrO2. Silica is made of SiO2. The blinds are made up of aluminum, which is Al. The window is made up of silica, which is silicon dioxide, SiO2. The backsplash is made up of silicon dioxide, kaolinite, and quartz. Silicon dioxide is SiO2. Kaolinite, Al2SiO5OH4. Quartz is SiO. Windowsill is wood, hemicellulose, cellulose, lignin, cellulose, C6H10O5N, lignin, C9H10O2, C10H12O3, C11H14O4. Hemicellulose is C6H10O5. Dish rack is made of polyethylene. It's plastic, C2H4N. For the fifth picture, the dresser is made up of wood, which is made up of cellulose, hemicellulose, and lignin. The hinges are steel. Cellulose is made up of C6H10O5N. Lignin is C9H10O2, C10H12O3, C11H14O4. Hemicellulose is C6H10O5, and polyester is C8H8N. Trash can is aluminum, so Al. The screen glass is silica. Exterior is aluminum metal, so silica is CiO2. Aluminum is Al. Mirror is made up of float glass, which is silica. Outside is made up of lead. Silica is SiO2. Lead is Pb. Bed is made up of wood, hemicellulose, cellulose, lignin, while mattress is made up of foam. Foam is polyester, so C8H8N. Hemicellulose is C6H10O5. Lignin is C9H10O2, C10H12O3, C11H14O4. Cellulose is C6H10O5N. Pillow is made up of foam, which is polyester, C8H8. Windows made up of silica, silicon dioxide, SiO2. The blinds are made up of aluminum, Al. Humans are made up of skin and bones. Skin is made up of keratin, actinolite. Bones are made up of calcium phosphate and calcium carbonate, as well as collagen. Actinolite is Ca2, Mg 4.5, 2.5, Fe2 plus 0.5, 2.5, Si8, O2, OH2. Calcium phosphate is Ca3, PO42. Calcium carbonate is CaCO3, and collagen is C2H5NO, C5H9, NOC5H10, and O2. The flag and poster is made up of cellulose and lignin. Cellulose C6H10O5N, lignin C9H10O2, C10H12O3, C11H14O4. Hemicellulose is C6H10O5. Carbon is made up of wool, which is silk. Silk is fibroin. Fibroin is GLY-SER, GLY-ALA, GLY-ALA. Silica is made up of wall is made up of silica, so SiO2. Trophy is made up of plastic, which is polyethylene, C2H4. Legos are made up of actinolite, but adiene styrene plastic, which has chemical formula of C8H8, C4H6, C3H3N. Curtains are made up of silk, which is fibroin, GLY-SER, GLY-ALA, GLY-ALA. Shirt is made up of cellulose, 100% cotton, C6H10O5N. And then pants, which are jeans, are made of either denim or dungaree cloth. Dungaree is made up of cotton and indigo plants. Cellulose has a chemical formula of C6H10O5N, and indigo dye has a chemical formula of C16H10N2O2. In the final picture, the metals are made up of bronze, copper, arsenic, phosphorus, or silicon. Bronze is made up of CuSN, arsenic As, phosphorus P, silicon Si, tin Sn. Paper is made up of cotton and pulpwood, which pulpwood is made up of cellulose, wood, and wood is made up of lignin and hemicellulose. Hemicellulose is C6H10O5, lignin C9H10O2, C10H12O3, C11H14O4, and cellulose, which is C6H10O5N. The monitor. The screen is glass, exterior is aluminum, so silica is SiO2, aluminum is Al. The lamp, they're aluminum, glass, exterior was SiO2, silica, aluminum is Al. The corkboard comes from oak trees, so wood, which is cellulose, hemicellulose, lignin. Cellulose has C6H10O5N, lignin C9H10O2, C10H12O3, C11H14O4, hemicellulose C6H10O5. The glass figures are made up of silica, SiO2. The cardboard is made up of paper, cotton is made up of pulpwood fiber, cellulose, lignin, hemicellulose, all that. Cellulose is made up of C6H10O5, lignin C9H10O2, C10H12O3, C11H14O4, hemicellulose is C6H10O5. Pencil is made up of wood is made up of cellulose and lignin, hemicellulose, graphite, and then cellulose is C6H10O5 and lignin C9H10O2, C10H12O3, C11H14O4. Hemicellulose is C6H10O5. The shelving unit is also wood, like I said before. The snow globe is made up of silica, which is the glass part, and the bottom is plastic. Silica is SiO2, and polystyrene is C2H4N. The stuffed animal is a velvet, which is from a textile, which is for Bruin, which is GLY-SCR, GLY-ALA, GLY-ALAN. The rubber caterpillar is made up of polyethylene. Polyethylene is C2H4. The cup is made up of polyethylene as well, so C2H4 because it's a plastic cup. The M&M container is also made of polyethylene, C2H4. Legos are made up of acrylamide, but adiene sterylene, which is C8H8, C4H6, C3H3N. The clock, the plastic interior, and the face is made up of glass, so SiO2 and C2H4. Thumbtacks are made up of nickel and plastic. Nickel is Ni, the polyethylene is C2H4N. The plastic toys are made of polyvinyl chloride, which is CH2 equals CHCl plus HCl. Erasers are made of polyisoprene, which is C5H8. From this project, I realized a lot went into the creation of the camera as well as the development of photos. Scientists like Abin Al-Haytham and Louis Daguerre were able to come up with such ideas not known at the time. Others like Wilhelm Röntgen were able to revolutionize the medical world through his discovery. I also realized how all parts of the camera are important and how they work in cohesion to allow us to take pictures, for example, the aperture and the shutters. Not only that, but we learned lights and the chemical makeup of the film allow the pictures to stay, and a whole process of photographic development, exposure, developing, fixation, etc., allow us to immortalize memories or points in time. The reactions in the lab taught me the relationship between them all and how silver trades electrons when the developer oxidizes. The lab gave me a hands-on experience with photographic development, and it's an experience I'll never forget. I was also able to learn the chemical makeup of all the solutions and learn a few new words along the way. Through the many hours I've put into this project, I was able to find some new formats for future projects, as well as mastering the long yet satisfying process of. I love my glossary live stream. I'm gonna follow along with my very own dictionary. Rectilinear propagation is the transmission of light in a particular direction or through a medium, consisting or moving in straight lines. A silhouette is the dark shape and outline of someone or something visible against a lighter background, especially in dim light. Lithography, studied by Joseph Niepce, it is the study of printing/writing using water and oils on a stone. Bitumen of Judea, an asphalt that was used by Joseph Niepce. It is a light-sensitive material and was used to complete one of the first photographic processes. Daguerreotype, created by Louis Daguerre. The daguerreotype was a photograph taken by an early photographic process, consisting of an iodine-sensitized silvered plate and mercury vapor. The image would end up on a silvered plate, while the image was made visible when the mercury vapor fuming with light. Collodion, using wet glass plates that were negatives. This photographic process was 20 times faster than all the previous methods, created by Frederick Scott Archer. Nitrocellulose, also known as gun cotton. This substance was used by Frederick Scott Archer in his collodion process. Gelatin emulsion, coated onto a substance of glass, filmed to make photographic images stay. Cathode rays are beams of electrons emitted from the cathode of a high vacuum tube, used by Wilhelm in the first ever X-ray. Negatives were when the lightest areas of the photographed subject appear darkest and the darkest areas appear the lightest. Exposure, step in photographic development, which is referred to as the time period in which light enters the camera and goes onto the film. Developer, step in photographic development when chemicals treat the emulsion in such a way that makes the latent images on the film visible. Fixation, step in photographic development which stabilizes the image by removing the unexposed silver halide remaining on the photograph, leaving behind the reduced metallic silver that forms the image. Stock bath is a step in photographic development when the development of the film, plate, or paper is stopped by either washing off the development chemical or neutralizing it.